So let's go back to the classification page. Got a looks like an eclipsing binary because the dips are alternating. Yeah, at least I think it is. Sometimes it can be quite difficult to tell the difference. Let's do the rest of these. Alright, now let's press done and talk. Someone thinks Nick's eclipsing binary. I agree, but I'm not 100% confident it is. It probably might just be. What am I doing? The link's here. Might as well click the link to the person who gives it. That's what it is, and I'm assuming that's just the same here. Yeah. Contamination ratio is extremely high. That's insane. There's more contaminants than there are actual proper measurement points. That's really odd. Alright, so yeah. He's already mentioned, put the link there, so I don't need to do the same thing. There's no point. So, eclipsing binary. And back to the classify screen. Let's check the size of the star. Yeah. Again, too big. These features are probably just pulsations, and they're not transits. So you can just go to the next star. It's another noisy curve. How are we at? We're at this curve 56. Now 57. I think we're going to 58 in a second. Yep. This one's difficult to determine. I think it's just another variable one. Because the data for the star's not there. Will these be transits? I don't. Might as well, I guess I can mark the ones that look at least obvious to me. Try and make a pattern if there is one. Yeah, I don't know really. Let's go done and talk and see what exofops. Oh, no, it doesn't matter. Let's have a look at this one. The to exofop. Oh, that's a lot. That's a lot of nearby targets. So I'm guessing this is in a cluster of some form. Oh my god. Is this a Wolf Rayet star? It's a Wolf Rayet star. So these are massive, really young stars that are on the verge of death, essentially. So GMP 94. Is there like a... Oh, I don't think there is. Let's zoom out. Yeah, this is part of the... Well, it's very close to the Large Magellanic Cloud. And they picked out this Wolf-Rayet star. So yeah, I think I was right to be hesitant because you're not going to find planetary transits around the Wolf-Rayet star using the transit method. There's just no way. These stars are far too bright. So Wolf-Rayet star. And the spectral type is... Apparently it's a binary as well. I'm sure I'll copy this, paste it. Binary, question mark. There we go. Classify, get the dark thing back. Here might be a possible transit. Let's have a look. I think I'll mark that. There's enough points there to make me think that it might be so. This was at day, I suppose day 21 point. Let's do 21.1. 21.1. So possible transit 21.1. Again, as we usually do, go to Exoplanets. Yep, it's not a TOI or anything, so let's go to Sinbad. It looks like there's an error in trying to missing declination and latitude. I think I put an error up here somewhere, but yeah, okay. I'm going to check this one on LC Tools to see if there's a due to a background flux or not. Alright, our suspected transit is here in this area. Let's highlight that. A closer view of it. Oh, man. Let's redo that. Let's go back. And then something like that. And let's go and connect the lines. So yeah, it's definitely significant because there's lots of points down here and they stay in this region down here. So let's get rid of that. Then Shift B. Ooh. Ooh. That doesn't look good. If there's no points here, then I'm pretty sure it's due to a background spike. Yes, it is. There we go. Yep. 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 So from that, we've just discovered that this transit large day 21.1. So transit due to contamination from a nearby eclipsing binary star. Nearby background eclipsing binary star, because that's a more accurate assessment. So yeah, fortunately that's not a planet. Let's go. We're at curve 60 now. This is curve 60. Check the star details. Another giant. There's a lot of giants this sector, from what I've seen. Just massive stars. So it's hard to find any planets around them. Got another noisy curve. There's nothing really significant. No. 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 Systematic effect up there. No. No. Let's have a look at this one a little bit closer. Don't think that is one. Let's look over here. No. No, I don't. No. No, let's go to the next one. Just check the size. Another variable star. No. No, nothing abnormal from that one. Got a pulsator here. Let's have a look. Anything that breaks the trend? Again, hard to tell. Possibly that, but because it's pulsating, it's probably unlikely. No, let's move on to the next one. Maybe this looks promising here, I think. There's so many measurements above it, though. I think that's just variability. Oh, yeah, I think it's variability, yeah. I'll just mark it anyway, why not? There's no harm in marking something that you suspect to be a transit, but yeah, okay. But the rest of the curve, no, we're done with that. So this is curve number 70. Systematic effect. Doesn't look convincing to me. No. 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 Let's go on. Next one. Ooh, what we got here? It's a big star. Don't know. Systematic effect at the start. Variability would normally imply big, but I'm not certain of that. Let's have a look. Sinbad. Yeah, big. This is S. Doradus. Yeah, A5, 1, 1A. Not sure what E and Q mean, but that usually means, yeah. Got a super giant star here. S. Doradus. Oh no, oh no, oh dear. Forgot to press the hyperlink button. There we go. S. Doradus. White super giant. Put evolved in brackets because it's what it states. It is on Sinbad. There we go. Classify. Back to dark. is this? Is that an SSO? I think that's an SSO. An SSO at D. Yeah, 8.5 looks like an SSO. What the rest of the curve? I'm assuming it is an SSO because it goes down and then immediately up like a spike almost. Yeah, looks like an SSO. So SSO day 8.5 question mark. I'm pretty confident it is, but yeah, all right. Let's just press that. All right, let's keep going. Noisy empty curve. Noisy empty curve. This is curve number 75, so 3/4 of the way there, and it's an empty curve. Empty curve. More noise. 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 Not noise, but too variable and pulsating for my liking, so done. Noise. .9. Let's zoom in a little bit. Let's check this one over here. No, that's not convincing for me. And I press done. More noise. Doesn't seem like it to me. Again, systematic effect at the start of the curve, squishes the whole curve, and it's hard to see anything really. So next. Got a variable curve, it's quite a hot star. B-type star. Yeah, now move on. Noisy. We've got a, it's probably a binary star. This curve 88. Might be an eccentric eclipsing binary. Looks like it. Check the size again. Do the radius calculation. Pretty sure it is an eclipsing binary. So 0.926 over the square root of 1.8. We get 1.24. Okay. Okay. But I don't think it is. It's probably one of these really small stars. This is sort of like the TRAPPIST-1 size sort of star you'll get. Alright. It's as good as we can do. And as you can see, someone's marked it as an eclipsing binary already, but we should make sure for ourselves. And we got TOA 99, not TOA, TOI 997. It's been listed as an ambiguous planetary candidate, so check. There's no observing notes on this one. It's a whole bunch of light curves done by professional astronomers. So the difference between an ambiguous planetary candidate and false positive is that this is They haven't completely ruled this out as a planetary candidate, but it's extremely unlikely to be one. And so they put it at the back of the pile, and yeah. So 21997 linked to Exofop. Listed as an ambiguous planetary candidate. Likely eclipsing binary. There we go. So to our next one. Curve 89. I think that's a good one. We got a kind of a giant star. Looks like an irregular. It's one of those weird ones that it's exclusive to giant stars. I don't remember the name of it, but there we go. Noisy curve, by the looks of it. Definitely pulsating around. Oh, it's another giant star. Come on. Why? Why so many giant stars? There's so many. We've got a little red dwarf now. That's not really a transit, I don't think. Another giant. Bloody hell. It's nothing that's completely abnormal to the variability of the curve. So I'm pretty sure there's no transits here. No, don't think so. This is curve 96. This is curve 97. Nothing. Curve 98. Nothing. Curve 99. Nothing. And curve 100. Might be nothing, but there's a big brightness difference. Check down and talk. So that is our 100th curve. So that's the last one I'm doing for this video, but let's have a look. Let's go to Exofop. And I think it's just like a really dim star by the looks of it. Yeah, it's just a very dim star. Just copy that. And Exofop link. And add the comment. And yeah, that's it for classifying them. So from classifying 100 light curves, they found out that 8 of them were good enough to mark a transit on. 49 of them were just empty, noisy curves. 9 were sort of like noisy-ish variable, sort of very difficult curves to look at transits at. 12 are just very clear variables. It's 6 pulsators, 4 eclipsing binaries, 10 giant stars, 1 white dwarf, and we had one simulation. So So this means that there are roughly 1 in 12 light curves which have transient light features which are good enough to mark on, for me at least. But this is only just from a relatively small sample size, so it's going to vary from person to person. But it does give you a rough idea of what you might encounter if you're planet hunting for a considerable period of time. So hopefully you found this interesting, and if it has aided you in your planet hunting efforts as well, then that is great. So thank you for your time, and goodbye.